Okay, this video series has now made it to day 5, and we are going to look at contact listeners in SpriteKit and Swift. I'm no stranger to these in the Objective-C world, but I am with Swift, and I plugged away for the past couple hours just toying around with some things. I think I'm ready to teach it. It's actually not that much different than it is in Objective-C. So what we'll do is create some body types here, and I am just going to work off of the previous project from day 4. If you want to do that, you can. Otherwise, you can just kind of watch this and enjoy what you see. So we're going to create body types. We're going to assign them as category BitMasks. So that's a fancy word, but it's basically we're just telling either our bro class or our object class that you belong to this type of physics object, and later on what we're going to do is test to see if those two types of objects contact each other. So first thing we'll do is create an enumeration, and this is going to be our body type, okay, and I'm going to put in here uint32, unsigned integer, basically kind of a simple integer, and we're going to put some cases down here so for each one of these. And we looked at enumerating previously in the series before. I believe we just had int. Okay, so we're just kind of making this a little bit simpler. And case, so this bro is going to equal 1, and then I'm just going to go with what I saw Apple doing, and what they did is, so this would be another body, right? They keep multiplying these by 2. All right, so if you just kind of want to get an idea of how to create more than 2 bodies, this appears to be the way to do it. And of course, I need to actually kind of give those unique names. Okay, and now that we've got that, we don't need to refer to these numbers. We can just refer to bro, ground, whatever it is. And now we will go into our didMove to view function, and we're going to write in here physics world.contactDelegate equals self. Okay, and that means that this physics world is now going to be responsible for handling these contact functions that we're going to write in a little bit. And you're getting this little error here because it says type GameScene does not conform to protocol SKPhysicsContactDelegate. Okay, in Objective-C you would write something like this. Well, let me get the code compiler to just fill that in for me. You'd write something like this to make that the delegate protocol, and of course we're getting a little error right there. It's pretty simple. You just remove those, and it stops complaining. And now this class is going to be responsible for the functions that we're going to write in a little bit. In fact, we'll just go ahead and put them right over here, and watch this when we write func, and then did begin contact. Look at that, it fills itself in for you, and even gives you the little opening and closing brackets. In fact, it does so much, you end up getting 2 of those func statements. Functions. I got to be careful how I say that. Did end contact is another one that we can listen for. And I'll just put a little note here. This did it again, didn't it? This gets called automatically, okay? We don't have to, we're not responsible for calling this, okay? That's what's going on with our little delegation there, all right? It's it knows that it's got to do some work, okay? And that work is right here in these 2 statements. This gets called automatically when 2 objects end contact with each other. And this gets called automatically when 2 objects begin contact with each other. Okay, now how can we go about testing that? Well, first off, we've got to go and assign these body types to their respective physics bodies over here, and I did end up taking out the physics body from our bro class, because I wanted to just write it a little bit of a different way that we hadn't seen before. But let's look at the object first, and that is our platform. And this we really just need one line down here, which is going to be object sprite dot physics body, and then category bitmask is going to equal to. And I thought this was kind of cool. I was expecting to have to write the same code inside of the object class. No, look at this. We just write body type dot ground, and that's going to specify it right there, dot ground. But we got to add one little bit to this, toRaw, and that seems to do the trick. And by the way, I could get away with putting the exclamation marks there, so forcibly unwrapping a value from this. But you know what? I'm still green here, folks. I don't realize the exact or the reason behind the difference between leaving that as optional or forcibly unwrapping that. I mean, to me, it makes kind of maybe more sense to just go, well, yeah, this definitely has a value. I just set it right here, okay? Or this property has a is not nil, so I'm comfortable doing exclamation marks there as well. Apparently what I can't get away with is doing that, okay? And what's the message you get? Does not have a member name dynamic. It's a strange new world to me. But all right, let's go over here, and we're gonna now set up our physics body in our bro class, which we did have before at the end of day 4, but I'm going to do it a little bit of a different way. So I'm going to actually create a variable here. I'm going to call this body, and I'm going to not let the compiler infer anything from it. I'm going to say that this is a SKPhysics body. Okay, so we're setting that class type there of the variable, and then we put in here SKPhysics body, and I'll define this or I'll initialize this the same way I did at the end of day 4, where we did a little multiplication of the image texture size. And let me just finish off that closing exclamation mark there. And then inside of this, we're going to write image texture dot size, and then dot width. Divide that by 2.6. 2, which would be, half the diameter, just isn't perfect with that particular image, so we're going to use 2.6 there. If you have a different artwork, feel free to change that number. And now we're going to write body dot dynamic equals true, and body dot categoryBitMask is going to equal now body type dot bro dot toRaw, so similar to what we did in the other class. And now, well, we got a couple more lines in here, but let me go ahead and associate this body variable with the with our class here, our Sprite SKSprite node. Okay, so if we were to run it right now, we're not going to see anything, okay? And he's still not going to have his physics body, okay? And I'm just going to prove that by building it. Okay, see, nothing's around him. We still got our little green bounding boxes around that guy. We do have to write self.physicsBody equals body. And the point of this is that, I mean, it is a variable, so it's something that can change over time, all right? So you could create a second body variable and apply it at runtime to our object here, our instance. So maybe at certain times of the game he, I don't know, has a circular radius, circular shape. Other times he's square. I mean, it's but there's all sorts of different values in here that you can change. For example, body dot affected by gravity. I mean, you can just go ahead and set that to true if you want. We do want them to be affected by gravity. Body dot allows rotation equals, let's make that false. We don't want them to roll around. Now, of course, too, you can change these properties without without having to necessarily create an entire second body. But, you know, I just kind of like to give you guys all sorts of different options. Okay, now let's jump back over here to our GameScene class, and let's write a little bit more code inside of our did begin contact function. And every time a contact occurs, we're going to create a new constant called let contactMask equal contact.body A, and then we're going to get the category bitmask from that. All right, so those values that we just associated with our physics bodies, and then contact dot body B dot category bitmask. So this constant right here is going to hold on to whatever category bitmasks just connected to each other, okay, contacted each other. So it's got two values here, and what we can do is write this really concise little switch statement that says, that just basically puts in here our contact mask, okay. And you know what, let me, before I do that, okay, yeah, I just want to see what value that was. Okay, so now our cases, or one of our cases, actually we'll just work with one for right now, is we're going to write in here case body type dot pro dot raw. That's fine, we could leave it at that, but let's also just put in here another condition that if this is also the case, all right, ground dot raw. So if that occurs, I'll do code in here. All right, so I'll put a little note that just says either the contact mask was the row type or the ground type. And this is okay for us for right now because there's really just two bodies in there anyway, and we don't really care which one was body A or body B in this scenario, right? And now we'll put in here default, and in this case, oops, just return, and let me pretty this up just a little bit. I think the only complaint here is that I'm not actually doing anything. Let's see, case label should have at least, yeah, right. Okay, I got it. I understand. Contact made. Well, gadzooks, that error just would not go away, and it's because I normally when we do OR operators, you have those double pipes, and even my notes for this lesson had the correct code in there, but it turns out that when we're comparing these bit types, this type right here, we go with, oh, I lost it. Golly, there it is. So we just needed a single one, and of course that led me to going, wait a minute, what am I doing here? You know, what is this thing? So it's a bitwise OR operator, and this is just coming from the Swift programming guide, and I'm on page 673, I guess, depending on if you're looking at the iBook version on the Mac. Oh, I lost my page numbers. No, it's still 673. So if you want to read a little bit more about that, but for now I would just go, it's still just an OR, okay? It's either one of these conditions is the case. And now you'd think, oh, okay, we can test this, and we'll get our contact made, getting spit out in the output window, but that is actually still not the case. And the reason is that essentially we haven't told the program here that we care about this contact, okay? Now remember, our physics collisions are still occurring, things like that, but we're not explicitly saying register this, okay? And what we have to do is come down here and write body dot and I always get these mixed up. Well, actually, I end up putting both of them on there. But body.collisionBitMask equals, well, for right now, let me just paste this in here, but we'll use ground. And then contactBitMask equals bodyType.ground.raw. All right, now let's watch what happens. Okay, sure enough, contact made. You see that 3 times because there is actually a little bit of a bounce inside of here. So he comes down, he bounces back up, comes back down again. I guess there's even another subtle little bounce that occurs. Essentially, we're saying that yeah, we care about this. All right, so pay attention to this body contacting the ground here. And this is kind of neat. Watch this. If we leave this out, or if we set this to 0, all right, what this means now is that we don't want our bro to collide with it, but we do want it to contact it. Does that make sense? You can see how this is a little bit confusing here. So watch now. He fell right through. But the contact was still registered, okay? So hopefully that's the sound that is coming out of your head right now as things are just exploding with possibilities, okay? So it's an object that went through something, but we heard about it, all right? From a game development standpoint, to me, these are the types of things that are still kind of just amazing. All right. So anyway, we do care about that, the ground getting connected here. And if we want to care about multiple things, we can go in here and say body. Jeez. When I'm like 1 centimeter off, and it occurs because my microphone is right in front of the computer, I just type anything. We can put in here another body. And then the same thing to raw. All right. So, and you could keep throwing these in here. So essentially, again, it's saying, all right, I care about this, or I care about this, or I care about that. But if you get rid of this, if you just take it out entirely, it cares about everything. All right. So it defaults to, just let me collide with whatever's out there. All right. But you can kind of break this down or isolate it down to specific objects, or leave out specific ones. So for now, let's I guess just leave in that, and then I'll comment it out. And you know what? Actually, well, before I do that, I'm sorry. Let me just copy it. I'll paste it down here. I do want to do one thing, which I know I tried. When I was just testing things out. I think it's worth looking at too. So I set that one back to 0, and then I'm going to go over here to my object sprite and just right over here, physics body dot contact, or I should say, again, I just messed it up, collisionBitMask equals okay. So essentially I'm saying here that this one, don't collide with anything, all right? Leave yourself out of it. But what happens if I tell the platform that I want you to collide with the bro? We'll see who wins out here, and I believe he's still just going to fall through. Yep, sure enough, he does. Okay, so doesn't matter. If one object says that I'm being left out of this collision equation by setting that to 0, everybody else has to kind of respect that, okay? And now, let's see. Let's go back over here to our GameScene.Swift, and we can go ahead and just paste in this exact same code right here. And this time, let's just write in here contact ended, and hopefully you'll get a little bit of a better idea of that bounce effect occurring. And oh, whoops. Well. Got to remember to take that out. I'll comment that one out here too. Put a little note. If you don't want this body to actually collide with anything. Okay, so here we go. Contact made, contact ended. That's when he bounced up. Contact made again, and apparently he bounced up just a little bit one more time. And then finally, contact has been made there. And if we were to move them around, okay, which we can still do because we still have some leftover code in here, you'll see that, well, that's very hard to tell what's going on. Let me stop it. Scroll it back up here a little bit. Well, yeah, I mean, you can infer what's happening here, but basically what goes on is the contact is still occurring even while he's moving along here. So I'm going to move him along. You'll see that there's no other output messages there until you get to this new one. All right, and then this body is contacting that one, so we get a new line printed out. And apparently we keep running into this guy and bouncing off of it because it's going back and forth between made and ended. But I believe contact is still persistently occurring between these two objects. So the contact ended here is getting spit out, I think, only from this one. So anyway, I think that's enough for this video on setting up contact listeners and actually listening to them.